example. We started this example in the previous lecture. We had a horizontal curve that we had a PI at station 6427.46 and intersection angle at 8 degrees 24 minutes with a radius of 2,864.79. We had to figure out our PC and PT stations, and here is the result of that curve data. If you don't remember that, or you need to take a review of that, it's in the lecture notes. Here's the example. So we set up, we have our PI station here, and we did the calculations of a length of curve, our degree of curvature, and our tangent length. Then we figured out our PI, our PC, and our PT. So take a look at this example if you don't remember where this data came from or how we got this curve data. But this curve data goes with this example. Now, using the equations that we talked about before, our deflection angles and our subdeflection angles. So when somebody says deflection angle, they're usually talking about the 100-foot increment deflection angles, or even the chord lengths. Subdeflections are usually the beginning of the curve and the end of the curve, meaning that that first length of curve is less than a 100-foot arc, and that end length of curve is less than the 100-foot arc. Everything in between station 63 plus 00 to 64 plus 00 is 100 feet. So we'll use these equations. Now, deflection at A is equal to SA over D over 200, or the deflection of A is equal to SA over I over 2L. We use this usually because we know the intersection angle in the length. We also know what the what the degree of curve is. It's up to you which equation. Now, you can rewrite this and make the I over 2L a constant, okay, and just replace it. So a lot of people like to use constant. It's really big when we start putting this into Excel sheets. Now, this equation here, the subdeflection at A, is the same equation for the subdeflection at B, okay? Now, the way this works is we're going to do 4 steps to do this in, okay? The first step is we got to figure all of our SA deflections and our subdeflection at the beginning. So our subdeflection at the beginning means, remember what I said, we started at 6217.008 and we went to 63 plus 00. So I'm just going to subtract these two numbers to get that arc length SA. That went the wrong direction. That's what this says. The full station after the PC. So 63 plus 00 is the full station after PC. So there's 82.92 feet in between those. Now, using the equation, and here's where the constant comes in. K, remember what we said about K. K is I over 2L. I is the 8 degrees 24 minutes. 2 times the length of curve, which was 420. That's on the first sheet. So that K factor is 0.01. Okay? So the degree of deflection, or the deflection angle at the very beginning, is that is the arc length times that K factor. That arc length was the 82.92 feet times our K factor of 0.01. So that subdeflection, if I go back, that first little bitty angle in here that goes from here to here, and remember the subdeflection is off of the PC and the PI up here. Okay, that's the degree we're measuring it off of. Okay, the second part is we figure the subdeflection at the end of the curve. Now, it's the PT minus the full station prior to it. So I'm going to go back. So the full station, or at the end station, is 66 plus 3708, right? So the full station right before it, prior to it, is 66 plus 00. So what we're going to do is we're going to take the end, 66, 3708, minus the one right before it, 66 plus 00. When somebody says full station, they're actually talking about the 100 mark. Okay? So there's 37.0 feet between those two, that arc length. So the degree of curve, or I keep saying degree of curve, the subdeflection angle at that is going to be the 37.08 times the 0.01. Okay? So that is the subdeflection at that point. Now, the subdeflection at the end, or I mean in between the points in here, subdeflection for the 64, 65, etc. I keep going backwards, sorry guys. Is going to be our degree of curvature over 2. Okay? Which is, we figured out the degree of curvature at the very beginning was 2 degrees divided by 2 is 1 degree. So that's our subdeflection in between. The chord length for the beginning, the end, and in the middle is going to be the equation here. So the chord length is 2rs subdeflection A. The chord length at the end is 2r sine subdeflection at B. And the chord length for the center is 2r sine subdeflection. So it's the same equation, but the lengths or the subdeflections at the end is what we're changing each time. Okay? So chord length at the beginning is 2 times total radius of an arc sine of our subdeflection that we figured out at the beginning. 2 times our radius sine subdeflection at the end is equal to 37.08. And the chord length in between at the 100-foot marks is 2 times the radius sine of 1 degree. Now, notice this. 82.92, that arc length is the exact same as the the chord length is the same as the arc length. At B at the end, the chord length is the same as the arc length. The reason is, remember we said, if it's less than 2 degrees for our degree of curvature, they're almost going to be the same. Notice the chord length in the beginning. We said the arc length was 100 feet, but the chord is 99.99. All right? So, using this information, we're going to put it into a sheet. So the way that it makes is, excuse me, is that subdeflection at the very beginning and reading from the bottom going up. The incremental chord from here to here is 82.92. The incremental chord from 63 to 64 is 99. 64 to 65 is 99. 65 to 66 is 99. And then the last one is 37.08. All right? Now, the deflection for between here to here, 62 to 63, is 0 degrees, 49 minutes, 45 seconds. From 63 to 64, that is always going to be 1 until the very end, and that subdeflection is 0 degrees, 22 minutes, and 15 seconds. All right? Now, the deflection angles that we're going to be using to actually measure across, we have to do the addition, the summation of it. It's like a cumulative. So we start with the very small, we start with the beginning, and we add it to the 1, and we get 1 degree, 49, 45. Add it to the 1, we get 2 degrees, 49, 45. Add it to the 1, and so on and so forth. All right? Now, this is how we do it for using the incremental method, or we use the subchords and the incremental distances. All right? I'm going to pause there, and we're going to go over how we're going to lay this out in the field.